Alright, good afternoon. We are continuing with 2.7 symmetries, even odd functions. We were done with the first half. We basically covered odd, even functions as symmetries here. We have two more functions to cover, special functions in this section. First one are piecewise defined functions coming next. And later we will see floor function or greatest integer function as seen in this picture. We are going to take a look at its properties. We will also discover what increasing, decreasing, and constant functions mean, find out their max and min, and that's it. So this section is pretty loaded, all right, but nothing too difficult though, not big computations involved. It's just a lot of definitions and new concepts. All right, where do piecewise defined functions happen? Actually, it happens a lot, and this is one real example here. Like your travel to school from home by car, you start your car and speed up, right? You were stopping and you speed up to 45 miles per hour. Let's say the speed limit is 45 and you shouldn't be exceeding it, so you go constant speed for a while, right? Like how many seconds? 1 minute you go constant speed, and then you go slow down, and in the parking lot you need to stop and zero speed, right? So as you see, it can be described by three pieces of line. Here is a piece of line. Here is a second piece of line. This is actually a horizontal line. And the last one is a decreasing, going down picture, piece of line. So there are three pieces of line or functions glued together here. Somebody trimmed them off, take the piece and glue it together and build a new function out of three simple functions, and we call it piecewise defined function because it's built by piece, one first piece, second piece, third piece. Okay? But if I just call it 2.25x, it's the endless line that goes all the way from left to up. Okay? It goes this way all the way from left to top. That's if I don't restrict anything. This is unlimited. But as I mentioned, we need to cut each line into a certain size, start and end points, and that size is always described here. So this is the trimming part. We trim the lines according to our need and paste it and put it to the end by end. Sometimes ends don't align. There's a gap or jump. It happens in piecewise defined functions, but this is a perfect one. All the ends meet in the perfect spot. There is no gaps or holes or jumps. Okay? So in this section, we are going to just explore them. Basically, we are going to graph them. How to make this final graph from three pieces and look at their further properties. Okay? And our first question is number 10. I put down three sketches here, three XY coordinates, because we're going to make three parts, three graphs. Actually, the question is only one part. This is what the main body of the question. And why are we doing part A and B? You have to do part A and B to make part C. So if I just put this part in the exam or test, then you still need to do part A and B. It's essential, okay? So kind of separating this into three parts, they're helping you out with the steps. So what is part A? They want you to graph this function. But this function is familiar to us from a section. Which section have you have seen this function or part of this function? This one is just from one section back, which is 2.6 transformations of functions. The first two slides I put down 7 main functions. I ask you to memorize their names in graphs. And this one is called absolute value function. I just need to know its graph. Can you describe it to me? Absolute value x only. From 2.6. It's a V shape. V, right? I'm putting this in dash because this is not the real final answer of part A. This is absolute x. Y equals absolute x, or f of x equals absolute x. You name it. It doesn't have this minus sign in front. This one is different. It's not absolute x only. Minus sign. Now again, back to 2.6 transformation of functions. What happens if you insert a minus to the in front of the function? It flips over x-axis. Yes. So this is going to go flip down, make a V shape, upside down V shape here. This is the one we are looking for, f of x minus root x, minus absolute x, sorry. You can erase the old one. We don't need it anymore. Alright. Are we done with part A? Is this the final answer? No, this is incorrect, incomplete. Why? I ignored actually one part. I didn't completely read the question. What is that part I ignored? What the heck this means? Is it just there for no reason? No, I just looked at it and made a picture, but I ignored this. What does this say? It says x values for, sketch this graph, but don't take the entire one. Trim it. Trim and take the part only where x values are less than 0. X negative, that means. So you only need to take the part of this red V shape, the part that lies under negative x values. So where are negative x values? Where are they? Which part is negative x values? Here is x. There are some numbers here. There are some numbers there. But which part is the negative side? The left side. So we need to take the part on the left. So you need to take your eraser and trim the part which is under or above. Sometimes it can be above, sometimes under. Positive side. We need the negative side. One more step. I am again careless. I didn't pay attention to something. Are you happy with the final picture? What did I miss? It doesn't just say left side. Okay, it says left side, but clean this off and take a good look at this inequality. Do you see any equal sign? That means where x is not 0, and in my picture it looks like I'm touching 0. So this means exclude 0. It's certainly negative, not being equal to, so exclude 0. So you have to take a hole and make it really visible. You're excluding that part. Otherwise, if you don't put anything, it looks like it's filled in dot there. So this is our final picture in part A. So, graph of f of x has an open dot. Again, open dot means it's not filled in. There is a hole there. So far, that's the only thing I can answer. We need to find out G and R next. Okay? Let's do G next. Alright, somebody help me with the graph of root x. Again, in 2.6 we did know square root x is, what does it look like? U shape? Root x, U shape? No, that's a trap. It's not U shape. What is it? Yeah, that shape. So it goes like this. Okay? But this one is a negative sign. That means reflect on across x-axis, right? Is it x-axis again? Yep. So you need to make this upside down and clean up the old one. Alright, question is, are we going to take, what part are we going to take? This means trim and take only the parts x is positive, 0, or positive, more than 0. So which side, oh, what a great picture. It doesn't have any negative side to trim off. It's already on the positive side. So there is no trimming required here. It's already a 0 or positive. All you need is just make sure you count that 0 in by filling this dot in. I want to visually see that dot is included. Here, excluded. Okay, any questions so far? We count in here because you have equal sign, exclude there because no equal sign. Finally, how do we use A and B to make the final graph? This is all you need to do. Look, part C is combination of both. It means, this means left side. On the left, your graph is gonna look like part A, absolute x with a minus sign in front. On the right, this is right side or positive side, you're going to make square root x, negative square root x, blue picture. So you need to just take these and move it down here. Okay. And this one as well. And that hole was empty. Look who's moving in there. This point is moving in there and it's going to fill this up. And let's make this final picture. Now you combine, glue them together. Let's make the final picture in same color. This is filled in green color. Alright? Yeah, I'm a little off, but you got the idea. Okay? So, problem over. Alright, g of x has a closed dot, but total, when you combine them, they are closed. And they want us to sketch negative root x, negative absolute x, I'm sorry. It was starting here, ending there. Next. G, the square root x was part C, right? Was this one, right? Mm-hmm. And the last, we need to pick the final picture. There are two similar ones, A or C. This side is straight, this side is curvy. It was A. Again, as you see, I didn't go with the options. I found my final result and picked the right option. That's the healthy way to do, okay? Alright, we're going forward, making a new picture. This time, how many pieces do you have? How many pieces of functions are you going to sketch first? 3 pieces. And all easy pieces, except the third one. This is a little bit challenging, but the first 2 is easy. Alright, let's do it together. First one, I'm going to picture in red. What kind of graph is this? Is it a parabola? It's a what? It's a line. Actually, what kind? Horizontal line. Y equals -3. Y equals -3 is a left to right straight line at -3. So let's go 1, 2, 3 here. Alright, quickly grab an eraser because you're going to do trimming. Y equals negative. We are going to trim. They do not want the entire line. They want a specific part of it. What part? The part x values stay between -3 and -1. Find x values -3 to -1. Where is -3? Alright, let's say 1, 2, 3. -3 to -1, -1. They only want the part between these two. So it's this part. Take an eraser and clean up everything else except between the part between these two lines. These two values. Here we are. Question. What do we do with the end parts, end values? Are we going to fill them in or leave them empty? Holes or filled in dots? Yeah, left side, on right side, what do you see?
Holes.
Holes because no equal signs here. One hole, another hole. Okay? And again, this level is -3. So this hole is sitting at -1, -3. -1, -3. This is at -3 and -3. We're done with the first one. Going forward with next one, x. Do you know the picture of x? I'm doing all three on the same picture. You can do separately and move them again, but I'm going to do it on the spot. What does y equal x look like? What is it? It's a line going to how? Which way? This? Come on, describe me somebody. How do you sketch this one? Origin. We start with origin. Which direction do we go?
Up to the right
This way.
and down to the left.
Okay, and this one to the left. So they will meet each other. Okay. Now I'm a little off. It needs to go through -3 and -3, right? So be careful. Don't do sloppy work like I did. Needs to go through this one. Alright, now which part are we going to trim? We trim the part between -1 to 4. Here is -1. Where is 4? 1, 2, 3, 4. I will take the part between these two dots. Okay? So take an eraser. Take this part off. You don't need it. And after 4 is here, take it off. This is the part we need. -1 to 4. The part above and under this region. Okay? I'm just curious what this level is. And shall we include any of the endpoints? -1 is included. Yes. So I'm going to fill this in. But we are going to skip this end. Okay? I'm just wondering what this coordinate is. It's -1 to -1, by the way. Yeah, -3 should be a little lower, but who cares, okay? Alright, last one. You see there is a jump this time, they didn't match. It's okay, sometimes there's a gap. The last one is, do you recall this? It's our famous parabola. However, this is the regular parabola. We don't want this. We want the negative of it. So I will take it upside down. This is -x squared. I reflected it along x-axis. But what does 16 do to it? 16
Moves it up 16.
moves up 16. So this one is going to go really up high here. So this is as high as I can go. Ooh. This is 16. Alright? And I'm going to plot it right here. Alright, however, we do not need any part of this. You need to go all the way down. Extend it all the way down, because why did I extend it all the way here? Because I've seen what part I need to trim. It says take the part where x values are more than 4. Where is x values more than 4? X values are more than 4 right here. Over this yellow region, you need to take the part of the graph, and that part is here. Not this one. So I'm going to clean all this up actually. I don't need it. I don't need any of these. I need the part more than 4. Go down at 4 and hit the curve. There you go, I hit it. So clean anything previously done. And only take the part after this red line. So it's pretty much nothing much. I'm out of space, but I think you have the idea, right? Question is, are we going to count this initial value in or out? In, because of the equal sign. There we go. And going that way further south. Alright? I don't need this anymore. Delete that. This is your final picture. Red, green, black. Go find that picture in number 11. Alright, until it loads up, let's take a look at the next question. We're stuck. Okay, here we go. So which one is more familiar to? Alright. I made a mistake, it looks like. I should have computed this value. Plug in 4 and check where the starting value is. When I plug this in 4, it's minus 16 plus 16, it makes 0. Mine makes like minus 5 or something. So I need to pull this one to 0 level like this. This is more accurate. This is a better picture. Always check the end values, okay? I got my list. Just take this value, enter it, and see where it's starting. And same here. Where is this ending? It's ending at 4, plug in for 4, and it's starting at -1. -1, and this level is 4. Okay? Anyhow, this is the correct part, right? D. Was it D? Yeah. Alright. Floor function. I like the name floor function better because that's what this function really does to the numbers entered. But the official name is greatest integer function. Okay? So how does it floor the numbers? Okay, here is how it does. When you enter a decimal or any number, the output is, when you put 1.7 there, so I enter 1.7 into that weird symbol. It's like double brackets. It's like weird double brackets here. But how do you compute that simple is, you are going to round off this number, but usually when you are rounding off, you look at the number past 1.7, which is 2, or number before 1.7, which is 1. You pick the closest number and you say 2, right? That's how you round off, right? But no, this function always go with the lower quantity, smaller pick. It picks the smaller number all the time. So instead of 1.7 between going for 2, it picks 1. It floors it. Okay, it presses down to the smaller whole number. That's why they call it greatest integer. We pick the greatest integer smaller than this number. What is the integer smaller than 1.7? 1. All numbers are 0, -1, -2 are smaller, but the greatest one is 1. Okay. How about this one? 5.5. What's this one? Still, we pick the whole number smaller than 5.5, it's 5. If it's already a whole number, what is the answer if it's already a whole number? -4, for example. It's already a whole number, the answer is -4 itself. But what if it's a -4.2? We always go with the small digit, right? Correct? So it is -4. -4.2 is -4. Agree? Right?
-5 is a lower number.
Yeah. That seems like, I mean, if I go with this reasoning, 1 is the answer here. You may say 4 is the answer, but no. When you take a look at -4 and -5, here is -4.2, -4.2 here. And this function, remember, rounds this off to not bigger case. It always rounded to the smaller case, which is -5 smaller. So the answer here is not -4, but -5. Okay? Alright? So here is its graph. Some people call this also step function. These look like steps, stairway, right? But as you see, whenever I put a number like -4.2, where is -4.2? Here, look at the value it hits. It becomes -5. If I put 1.7, where is 1.7? Here is 1.7. I go up and I hit this value. What is this value? It's 1. Whereas 5.5, I'm out of screen. Alright, where is -4? At -4, you are hitting this value, which is -4. So at whole numbers, it turns to itself. Whole numbers are itself. But all other values in between, you go with the lower choice. Lower, okay? Alright, we just do a small activity. I'll just do it on this picture already. This is the original greatest integer x. They want us to sketch greatest integer x, take away 3. They have reduced x values by 3. So I'm guessing there is a transformation going on here, but which way? Up, down, left, right, stretch, shrink. What kind of transformation? It's down if this 3 is the end, on the end, like this. This is down, outside the function, it's down, but this is not down. It's right shift. So all you need to do is shift all these steps 3 unit right. So this is going to go from 0 to 3 and a whole. And then 1 up, right, always this is how it progresses. Once you get the first step, you know how you go on the stairway, right? You just need to go up, right, and this way, down, left, down, 1 left. So it's just shift 3 units down, right, okay? I just put this so you can get familiar with this picture. It's just the stairway. Alright? Next item we're going to learn about functions is to find out where they are increasing, decreasing, or flat, constant. Okay? So how do I know a function is increasing? You need to always imagine yourself moving on this path from left to right. Imagine yourself moving from left to right. Answer this question. Are you climbing up or are you sliding? Here, when you go from left to right, this direction, what kind of effect do you feel? Climbing? Going down. Which way? Climbing. Then that moment should be recorded on x-axis. So you smash this down on x-axis. And we say whatever these end values are, you read these a and b. You say between a and b, this function is increasing. Okay, we don't go climbing or stuff. The technical name is increasing. But what's mathematically mean is whenever I take a number on the right comparing to a number on the left, its value on the right should be greater than the number on the left. Decreasing means the number on the right should be smaller. This time x2 is on the right. You see? The number on the left this time is bigger. Okay? And constant means constant is flat. It doesn't change at all. It's always, no matter what numbers you take on that line, it's always equal to each other. No increase or decrease. Okay? But in the questions you will be asked to find intervals over which the function is increasing or decreasing. So this is the work you're supposed to do. You always smash this down and check out what 2 numbers this thing is going down, such as this one. Now we are going to first find out the intervals you are climbing. Alright, let's color first in green, okay? Green parts where this graph is rising. You're rising. Is it here? No, I'm sliding, going down and down and down and down, and I stop and I start climbing up. So this is the increasing part of the graph up to here. So you need to push this down. No, where is the x-axis? So you need to push it against x-axis. This time it's up. Push this up and read over which interval this green piece corresponds to. So this point is, you can read it here too, is -2. So I'm going to color it here. It starts at -2. And when does it end? At 2. This yellow region tells us where it's increasing, which is -2 to 2. All right, here is the question. Are we going to count the end values or not? Are we going to use brackets or parentheses? All right. So do you want to count this end value as a climbing point or sliding point? Because it can be a part of slide as well, right? It's neutral. On those points, we can't push them into either set. We leave them neutral, undecided. So we don't count them in. We exclude them. Because we don't know really what type point they are. So use parentheses. Okay? We use always parentheses in this question in any part. Okay, second part. The second part. This time we are going to answer where this thing is going down. Where is it going down? Here. You just need to color what region corresponds to this part. And I see we're starting here and this region. Goes all the way to the left though. Unlimited, because this arrow keeps climbing and climbing. So how do you write this yellow shade? Always from left to right you need to read it. Negative infinity on this side up to -2. Where is it? Constant. This is a no-brainer. Constant part is this. So its shade is this, which is 2 to 3. Correct? Okay? Any questions? I will just, yeah, it's, you need to first do a bogus part. It says, yeah, sometimes increasing, sometimes decreasing, and sometimes constant. Increasing part was -2 to 2, right? Check. Okay, I think we're good. And the last question. We are going to, last question involves finding maximum and minimums. Relative means local. Basically, maximums are little bumps on the path of this curve. Do you see a bump on this curve? Yeah, here we go. Why is it called relative though? The other name for relative is local. Because for people living in this region, this is really the highest peak point for them, right? What is the biggest mountain in the United States? I'm not good at geography. Highest peak point in the United States? You never know?
It's in
Oh.
Alaska.
What?
I know it's in Alaska.
Alaska? Okay. So for those people who never left the United States, I mean visited all places, you think this is the highest point on Earth. But if you go to, where is Mount Everest? India? Nepal? Nepal? Yeah, when you go to Nepal, those people see real monster giant mountain. So it's their local. This is their local max. But when I think whole Earth, this is actually absolute maximum. So that's the difference between relative and absolute maximum. Relative, it means in this neighborhood, yeah, this is the peak point. And same way, are there any cavities in your path? Yeah, there are some valleys. And this is the deepest location on the valley. It's called relative minimum. You just need to look and find that. That's it. All right, by the way, the formal definition of them is listed here. You need to find such a nice value, A that when you go a little bit to the right and left and pick any number else other than A, those values of F there still be lower than this blue dot. Okay, that's what relative maximum means. Relative minimum means you find such a deep down point somewhere in the path. When you go a little bit to the right and left, pick any value you wish, those values stay always more than the value you picked. Okay? These are formal definitions. All you need in this section is to know visually what local max, local minimum are. In this graph, you have several local maximums and one local minimums. Can you spot them? There are two parts you need to make. Location means x value of the peak point, x value. And if I say they want the value, that means y value of the peak, okay? If they ask identify value of the maximum, they are asking for y. You need to point out how high this mountain is on y. And if they want location, you need to look at its x coordinate and find it. So where is our first maximum on x-axis? Where is the peak happening or bump? At -2. This is the first one. -2, but its value is, how high is it? Its value is 2. -2, comma 2. Let's see what kind of answer are they accepting. So the function has how many maximums, peaks you count? 2. No, this is minimum. So it's 1 minimum, right?
Yeah.
1 minimum, but 2 maximums. Maximums are at -2. Where is the other one?
2.
The other one is at 2. And the values happen to be the same. Look at the height of both mountains. They are equal, right? They are equal and that height is 2. So you just need that maximum single value. Look, how about the minimum? Where is the minimum happening?
0, 0.
It's right here. Oh, its coordinates are 0, 0. That means located at 0, but the value is 0 as well. 0 is the location, the value is also 0. Okay? Alright, 2.7 over, but we are going to continue in the remaining 10 minutes to 2.8, okay? Any questions? We good? Okay. In 2.8, we are going to perform 5 operations between functions. 5. So, what are they? Addition, multiplication, subtraction, and division, the first 4, just like numbers. Number, addition, multiplication, division, you're going to do pretty much the same thing, except the 5th one, which is not here, it's called composition. This can be pretty new for some of you guys and can be challenging as well. The 5th one is a tricky one we're going to take a look at probably tomorrow. We will first learn how to add, subtract, multiply, and divide two functions. Two or more sometimes, but usually if you learn two, you can add the third one later to the first two. Alright. The idea is very simple. When you see this symbol, that means you're combining these two functions by addition. All you need to do is to compute this addition, you need to combine their formulas, expressions, by this sign. So you need to combine these two by addition. That's it. It's that simple. Alright. What is difficult here then? Domain finding can be challenging. So in every part, they will first ask you to build the new expression. So it's x squared plus 5. They just simply want us to join them by addition. And yeah, they want us to graph this thing. But don't you know how to graph this? Look, don't peek at the solutions. Look at this. X squared is a U-shaped parabola, right? And somebody added 5 to it. What happens to your graph? It transforms where? Up 5. So find the picture that starts at 5, 0. I think it's the first one. A U-shape, not V-shape. The first A, B can be the right choices, but A is the one going up, so it's A. Alright. Next, we will subtract them. I want you to take a look at this. It says what we are going to do with their equations. However, something is different. What is different? Yeah, it's subtraction. We flip the subtraction, but what do you see here? Comparing to this. Here you have worked with x values, these expressions using x's, and computed this as x squared plus 5. You did not need to modify this because this was x, same as here. In this question, it's negative 3. So what is the difference? Not much. By the way, you won't use f here. In your set you may, but not in mine. In my set I need only g and h. Says subtract g and h. G minus h minus 3 means copy down g, copy down h, and subtract them. However, not with x's. Instead of x, use minus 3. So all you need to do is enter minus 3 before using this one in this line. Don't use x, but instead use minus 3 and compute this, and then subtract h of minus 3. It means h, but instead of x, use minus 3 because I see minus 3 here. Okay? So it's 1 over minus 3 minus 7. So what is the difference again between minus 3 and x? If this was x's, I would keep these x's. It's not, I'm making them minus 3, that's it. And we have to go all the way through and do. What is minus 3 plus 6?
3.
Positive 3. What is absolute value for the positive number? It's the number itself. How about this? Minus 3 minus 7 makes minus 10. But this minus and this minus combine into positive 1 over 10. Well, you need to add these two numbers, but one of them is a whole, the other one is a fraction. You need to make this 1. Multiply both sides by 10, making this 30 over 10. Now they have a common denominator. The answer is 31 over 10. Do not use calculators for this. 31 over 10 is fine, okay? Does it make sense? Alright. So this is it. Take a look at next one. We are dividing in the next one. I made a mistake. Where's my mistake?
The online one had 6 instead of maybe 3.
Okay, so I didn't make a mistake. Yeah, I just solved the wrong one. Okay, so mine has -3, online one has 6, so that's why I didn't like it, but you don't have a mistake. Okay, how about this? Let me make sure it's the same thing. Yeah, 7. No, we are doing number 4. We're skipping 3, very similar. Number 4 has 5, so I'm going to make 5. This is 5. Alright, you know what to do. H over G of 5 means you take and compute H at 5, and then you take compute G at 5 and divide them. This means division. So let's compute. By the way, we are not using F anymore. It's G and H only. Take the formula for H. Where is it? It's here. And compute 5 there. 1 over 5 plus 5. So you can actually compute it right underneath if you want. H of 5 is 1 over 5 plus 5, which is 1 over 10. And take it here, the 5s. Now compute G of 5. Let's compute right underneath this, which is nothing but 2. Agree? Do you agree? Okay. And I cancel this. This is 5. 10, 2 goes to 10 5 times. And make the result. This is just 1. 1 over 50 divided by 1 is 1 over 57. Right? Okay? Any questions? No questions?
Are you supposed to multiply 2 and not divide it?
Yeah, this is wrong. I made a mistake. 10 and 2 cannot cancel because they are not on the same side. This is 2 over 1, 1 over 10. You're dividing denominator of this thing with the numerator of this thing, and it's not gonna work. I wish 10 was on the top. Now it could work. So how do we do this the right way? Let me clean this up. It's not 1 over 5. It's the safe way is whenever I see a complex fraction like this, I flip this and multiply with the top. Flip and multiply. The safe way. So 1 over 10 is the top. So I don't touch the top. Just bring it here. Take a product, multiply with, flip 2 over 1 as 1 over 2. Now we see that in reality it's 1 over 20, the right answer. You had 1 slice out of 10 slices of pizza, and you are dividing it 2. Of course, you will have 1 over 20 less pizza, not more pizza like 1/5, right? That's the reason. Okay, so this is where we're going to start today. Tomorrow we will take a look at domain and composition of functions.